Here we are, our last video for microbiology. So this week's video is on fermentation, and I decided to venture into unknown territory and do sourdough starter, something I've been wanting to do for a long time, but didn't really think that it was something that I could do. So this is a nice way to kind of force me to do something a little bit outside of my comfort zone. So the microbes involved in the process are lactic acid bacteria and yeast. And so the yeast is what creates the carbon dioxide and the bubbles that are formed in the dough. And the lactic acid bacteria is what provides the sour flavor. And so that comes in the form of acetic acid and lactic acid, which are also used to preserve the bread by lowering its pH, and it prevents the growth of any foodborne pathogens from entering into it. And I got that information from Serious Eats website. So that was really cool that I was able to find something that was able to explain the microbiology behind sourdough. So the purpose of adding the ingredients to the recipe. So this wasn't like a quick active yeast that I added. The only thing that I began with was organic unbleached all-purpose flour and purified water. And then those have gone through the fermentation process, which has created the lactic acid bacteria, as well as the yeast inside of the dough. And those that reaction had been able to be seen within the first 24 to 36 hours of beginning the starter. The metabolic processes the microbes are undergoing. So the yeast is produced by natural fermentation of the flour and water, and that is called Saccharomyces cerevisiae. I think that's how you say it. Or common baker's yeast, which is used in both baking and the production of alcoholic beverages like beer. So in order to reproduce, most yeast convert simple carbohydrates or sugars to carbon dioxide and ethanol, and this process is actually alcohol fermentation. So as the yeast continue to feast on the available sugars, they begin to multiply. The production of carbon dioxide creates gas bubbles in the dough, which when trapped in a well-developed gluten matrix, help to expand the dough. When baked at a high temperature, the bubbles expand further and more carbon dioxide is produced until the yeast dies off, and that results in those bubbles and the airy sponginess that are in bread. So lactic acid bacteria is also naturally occurring in the dough, and so lactic acid bacteria digest simple carbohydrates, but instead of the alcohol created by yeast, lactic acid bacteria produce the sour lactic acid as a byproduct. Again, I got this information from Serious Eats sourdoughstarterscience.com. The changes that occurred in the food during fermentation. So as far as the oxygen goes, on top of my sourdough starters, so I have glass vessels, glass mason jars, or bigger cylinder jars. On top of all of them, I've only placed just a plain old kitchen paper towel and a rubber band to secure it in place. So the oxygen is able to just go in and out. It's freely moving. There's nothing that's obstructing it. And so it's obviously whatever's in the oxygen is also contributing to the fermentation process. The amount of carbon dioxide also increases daily. You can see through the number of bubbles inside of the dough that are increasing, and you're able to see these when you're feeding your sourdough and when you are discarding your sourdough. So as soon as you go into it, you'll see that there's these huge air bubbles, and it just is so stringy and just full of air. It's really cool to actually watch it. The production of lactic acid, as well as the acetic acid, actually lowers the pH of the starter to around 3.5 and as high as 5. The lowering of the pH results in a characteristic sour flavor of sourdough, and low pH eliminates any unwanted pathogens or any different microbes from being able to enter into your dough, and it actually can't survive because the environment is so acidic that they're not even able to do anything inside of there. Sourdough starter ferments best in a stable environment between 70 and 80 degrees Fahrenheit. So this was actually the trickiest part of this experiment for me. I live in an older house with not a great HVAC system, and so our house is just really cold. Generally, we have a subfloor, and so that just kind of contributes to the coldness inside of the house. And so what I was noticing after the first starter was that the environment just wasn't correct. I put it in my kitchen. I thought that was a warm place. I put it by the oven. I think I actually put it on the burner. And thinking, oh, well, that's going to be a good enough environment that my sourdough starter is just going to flourish magically first try. Well, that didn't happen. I actually had to throw out my first sourdough starter because I didn't have my ratios correct. And so, yeah, I had too much water to my flour. And so there was just too much fermentation that was going on. And so I had to start over. So ultimately I was successful. So today is actually the first day that I was able to use my discard, and I made sourdough discard cheese crackers. They are literally like homemade Cheez-Its, and they are delicious. My husband loves them. I love them. There's definitely some stuff I'm going to do differently next time, but I will get to that. I know that tomorrow I can use my discard for sourdough cinnamon rolls. So guess what we're having for breakfast tomorrow? Really excited. And then what changes would I make if I was making the food again? So I failed so many times at making this sourdough starter, and that's actually what's caused the delay of me being able to record this video, is that I wanted to have a product that I could actually use. And so my first sourdough starter failed. I had too much water, and it actually created this, this liquid on top of the starter that turned to mold. So obviously I'm not using that. So I threw that out. And then the next starter that I made was in the cold kitchen, and it had too much flour to water. So it was an original 2-to-1 ratio. And it was just too much flour that it formed a hard exterior on the top of the starter. So I just threw that out. The third one that I started smelled so bad because I had neglected it, because I thought, well, maybe I'm just touching it too much. And so the third one we had to throw out because that smelled so awful. There was no way on God's green earth that I was going to consume anything from that. So the next one that I started are actually 4, 5, and 6, which are still alive right now. I decided that because there was such a delay in me being able to record this video and to do the product, that I actually just needed to do 3 separate ones. So I started one with organic whole wheat flour with the 2-to-1 ratio. I started a separate one with the organic unbleached all-purpose flour. And then I began one with all-purpose flour, so bleached all-purpose flour. So I currently have 3 starters. All 3 are successful. This morning I kind of noticed a little bit of a sour-ish smell, so sour milk. And reading some articles that said that my dough was actually neglected. It was starving. So I ended up throwing out 75% of each of my starters. And then I actually found a different ratio quantity that I used and will be using moving forward. So it's a 1-to-1-to-1 ratio. So that is equal parts of discard, of organic unbleached all-purpose flour, and then also of purified water. And so that's actually what I added to all 3 of my starters this morning. And they look so much different than what I started with. And I think that the problem with this experiment is that I didn't know what sourdough starter was supposed to look like. I think I had this idea that it was supposed to be this like dough mixture, and it's actually supposed to be a lot more liquid than what it was that I was starting with. And so I don't know how to upload videos onto this or upload pictures. And so I'm just going to show you the process of what I went through. So this is my first starter. It's a 1/2 cup of flour and a 1/4 cup of purified water. This was the first whole wheat one that I had to throw out because it formed that liquid on top. This is a separate sourdough starter jar that we actually ordered. And so it has a band for feeding as well as a sticky thermometer that you put to the outside. Later that day, these were both of them. And then that one, you can obviously see it's doubled in size. And I think that was over 7 hours that we had seen that happen. And so this morning, this was the discard that I was making into dough. This is me getting the dough into the new flour, the cheesy crackers before and after. Like I said, homemade Cheez-Its. So there goes an expense that I don't have to pay for at the store. Thanks for watching.